Okay guys, let's model the third and fourth floor as well. So before we do that, also remember there's something I forgot to check in the first session right after modeling the columns. So I think it's very important that when you are done with modeling the column members, one should like check the direction and the positioning of the columns. And to do that, let me try first and try to hide the slabs and the beams so that we can be left with only the columns to do the check. Because the check I'm talking about is, you can see that like here from the floor plan, some columns they are strong side, they are looking in the y direction. Others they are the strong side is positioned in the y direction, in the x direction. So this is very important that we keep the same positioning in the modeling as well. So let's do that quickly. So to hide the slabs and the beams, I just have to use this. I just need to select them first. To do that, I can use this selection property. So I can select the areas for the slabs. So I come here and I choose my slab, select, I click select, and they are selected. And also I can, for the beams I can do the same, select properties, frame sections, and I choose the beams. I click select, and also they are selected as well. So when I do that, I can right click and do to remove the things I selected, to remove them from the view. Now you can see that we are left with only columns. So now I want to tilt the view and look it from the top so that I can check the setting if this is the same. I can try to do like by clicking shift and try to tilt the view in this way, or I can create a view, an appropriate view from the edge, from the view, and set 3D view. So I want to have a view in the XY plane, so I click here and I set the aperture to be 0 so that like I can select from the angle of 0. When I click apply, you can see that I get like a very good top view. So let me maximize the view here. So and bring these windows as well. So what I want to check is to see if I did the right positioning of the columns. You can see that like for the square one it doesn't matter, but for the rectangular sections you have to be sure that the strong and the weak sides, they are positioned in the right direction. So as you can see, like we did well the modeling. So now we can be sure that even the analysis result will be correct. So let's continue with modeling the third row. So I come back here and let me go back to the XZ plane. And before I do that, I can bring back everything that I hid by clicking here, right click and say show all. So now you can see that our slabs and columns are back. So for the third and fourth row, we have the section, they are like this: S1, S2, S3. So S1 is 25 by 35, 40 by 40, and 30 by 30. So let me do that quickly. I click on the draw frame tool, 25 by 35 as the S1. But remember that I have to come to the first grid. Now I'm in the middle, as you can see. So I do like this. Now I'm the first. I can now draw the third row, and I choose here again 40 by 40 column, and I draw it in the middle. I choose another section. It is 30 by 30 column, I think, and here let me check. I did the right. Okay, I chose the right So as you remember that this first grid is similar to the third one, so I have to just replicate these columns to the other side like this. I choose them, control arrow, and then they are in the right direction at 7 meters away, so I have to replicate them one time. So I have to put the increment data to B1 and I click apply. As you can see, they are successfully like replicated. Now I can come to the second grid in the XZ plane so that I can model the middle columns. So the middle columns, they are like this. So we have S2, SO, S2. So S2 is 40/40 and SO 45/45. So quickly I can do like this, 40/40 in the corners, and in the middle I have to use 45/40 column. So now I am done with the columns modeling. I can quickly go ahead and draw the beams as well. So to do that, I come in the XY plane and I move up until to the third row. So I am there, so I choose the beam section, which is this one, and then I go ahead and draw the beams. So remember the methodology, like from left to right and from south to north, like this. One second, I don't know my mouse. Okay, now I'm done with the beams modeling. Now I can go ahead and also the same for the slabs. So now I have every member already like modeled. Can check again in the view. Can see that successfully like did well, and then I select again the the slab and I assign the loads. Assign area loads, inform to shell. So if you remember, I think the live load, yes, it is 2 kN per meter square in the normal flows. Well, because like the third and the fourth floor we have like different loading, because the fourth floor is the roof, maybe I can assign the loads separately. So let me go ahead and replicate and assign the loads separately. So to replicate this flow, I just have to set this view to the 3D and I shift click and tilt it so that I can have like a better view where I can select easily the third floor alone. So you can see that all the columns and the beams for the third floor, they are selected. So I can replicate it to the fourth floor by doing the replicate command 0, and it is 3 meters above in the Z direction. I click on apply, then there I have my whole breeding like is set now. So let's go ahead and create and try to assign the loads as we spoke. On the third floor I can assign using the area loads inform to shell. So here I will be having like dead load 1.5 and live load of 2 kilonewton per meter square. So the live load is correct. I click on apply. I do previous selection. I put 1.5 for the dead load. Click on apply, and then I go up. 1 second. So from here I can go in the last row. Yes, now I'm in the last row. I click on the slabs and I do assign area loads. So in this case the dead load is how much? It is the same, but the live load decreases. So the dead load I apply 1.5 previous selection, 1 for the live load. Then I click on apply. Okay, so now that we are done with applying the loads and the modeling, now I think it's the right time to perform the I think we can also assign the support. I think it's a good time that we assign the supports. So let's come in the XY plane and I move down to the last row. So I select the last row joints, as you can see, and come here to assign joints, restraints, and I choose the fixed base one and I click on apply. So you can see that our supports are created. Now I think there's something very important you have to observe here. Also, we should consider, I think, and that thing is this one. I don't know if you can tell from the 3D view here, but there are some, like the beam and columns members, they are crashing because SAP2000 like just models the 1 second. So in SAP2000, so let's say this is a column. When you model a column, it is set like this, and when you model a beam also, it comes like this, and it is entrapped in the middle of the column. So this part here is excess, like the beam should start from the column face, right? From here, it should start from here, not inside the column. So in SAP2000 there is a property to account for that, which is called end of length offset. So when you apply that property, the program will automatically like remove this part from the entrapped part of the beam and columns from the members. So let's do that property immediately. So let's select the beams and the columns and apply the property. So to do that, I come select properties, frame sections. I come here and I select all beams and columns, and then I come to assign frame end length offsets. So here I can do the automatic connectivity and set the region zone factor to 1, which means that the beam and column joints, they are supposed, or they are assumed to be very rigid, and I click on apply. So now you can see even in the view that it changed. You can see that some the columns and the beams they are somehow reduced. So after doing that, another important thing I think we have to do is to go ahead and mesh our slabs, because currently we set them to be like shared things. So the slab type, and now if we were to run analysis, we won't be able to read the moment or other like shears, everything, because like currently the loads at the slab level, they are only transmitted to the beams and columns by only using these 4 points. But in reality, the loads from the slab, they should be able to transmit or transfer their loading to the nearby beams at every level, at every centimeter. There should be some loads like transferred, not only at 4 points. So to do that, we have to divide the slabs into many parts by meshing them, so that at every small like slab can easily transfer the loads to the nearby beam. So to do that, I just have to select the slabs by selecting using properties, area sections. I click the slabs and I click on select, and then I come here, use edit and edit divide areas. So to divide areas into small parts, I can come here and use the first option, which is like you choose like to divide the slab in the X direction. Let's say one slab here, this is 5 meters in the X and 3.5 meter in the Y direction. So along the X direction, I can divide it. I chose to divide it in 10 parts, and in the Y direction 7 parts. So at the end, I will have like a small like slabs of 0.5 meters of like length and width. So normally, like to decide on how much, like how small the meshes should be, it should be like very small, that you will be able to accurately like represent or to get the good results. And also they should not be very small, so that the computation effort couldn't go higher. Like because if you make like them like 0.1 meters or 10 centimeters small, then like the analysis time we increase maybe to 30 minutes or like to a long time, and it won't change too much thing in the results. But also you have to make sure that you don't make them very big, so that the results are not accurate. So I think in our case, also in order to gain time, I just choose like set them to be 50 centimeters each. So when I click on apply, now you can see that my slabs all are divided, and they are turned into small like pieces. So in this case, now every slab, every small slabs here is able to transfer the loading to the nearby beam easily, which is the right way the load transmission should be carried out. So after this part, I think we can even also we can set like our diaphragms, or we can assume like our rigid diaphragm, because our breathing is like a very symmetrical breathing, luckily. So we are expecting that when like earthquake occurs or any vibration, our breathing is going to vibrate like in one direction, and all the points at every floor we have like equal displacements. So since that is the case, to do that, like to do that assignment of like rigid diaphragms, I have to come here and define, assign joint constraints, I think, yes, and then define the constraints. So and the constraint here it should be set to diaphragm, and then add new. So this is the diaphragm one. So how many we need? 1, 2, 3, 4. We need 4 diaphragms set. So this is the one, and add another one, and add another one, and add another one. So we have in total 4 diaphragms. So to assign those, like I want to assign, like you see that we have many joints at every level. So when you assign like a diaphragm, any joint at the same level, we have the same displacement in when the earthquake load is applied. So let's assign these ones. So let me move to the first row and select all the joints at the first row. Oh no, you are at the third one. So I select all the joints and I click on diaphragm 1 and I click on assign. I move to the second diaphragm 2, I click on apply. I move to the third one, click on diaphragm, and then move to the fourth one. I assign the diaphragm on the last one as well. Click on apply, and then we are set. So like for example, if you click on one joint here, you can come here on assignment, and you see that we have like a constraint already assigned, diaphragm 4. So now this part, when this part is done, so before we go ahead and continue with our analysis, I think there's one thing I have to fix before we go ahead, and it is in the load patterns. Yeah, I think we didn't define where the dead loads in our modeling. So this is correct, the dead load, this one is for accounting for the weight of the breathing, but I think we have to add that dead loads as well. So I click here on more, I click here on super dead. So super dead it stands for the loads that are like superimposed, like let's say the finishing or the flooring, all those type of loads, they are all like in their type is super dead. So I have to assign that, but the self weight multiplier should be 0 here. So click on add new, and remember that we have a wall on the outer perimeter beams, so that one also should be assigned as super dead. I click on add new. So now we have all the dead load assigned correctly. So remember that when we are assigning this like dead load here, remember that we were using like the dead load, like the dead load pattern, which is not correct. So because I don't think that this 1.5 kilonewton per meter square is the safe weight, this is the superimposed dead load, so it shouldn't be like assigned using the load pattern of the safe weight. So we have to correct that, and it's very simple to do that in SAP. So what I was saying is we use this dead type when we are assigning the 1.5 kilonewton per meter square instead of using this on the superimposed load pattern. So to do that, I go ahead and I select the areas by using property selection. So I click the S14s. So now I just selected all the slabs where I assigned the loads. I click on area loads, uniform shell. Now that I'm going to replace because already there are some assignment there, but because I'm going to change it, so I'm going to first delete what I assigned there as dead and set them to 0, and do previous selection again, and put, instead of dead load, I click on superimposed load, and I click this to be 1.5 because I think for all the flows is the same, so I don't have to change anything. So I just write the same 1.5 and I click on apply. So I think after that you can come here, 1 second, one can come here and choose and check if the assignment are correct. So in the loading you see you have live, which is correct at the top row, and superimposed like dead load, which is 1.5, coordinate parameter, which is correct. Yeah, so now we can go ahead. When you click here you get like undeformed shape view. So now here also I think we can go ahead and try to create the mass source. So the mass source of the breathing, so we are trying to tell the program what kind of like criteria should follow to calculate the mass for the breathing, like that will be used maybe in the eigenvalue analysis, which is the model analysis, and to calculate the seismic weight. So already you have like a default mass defined, so I can modify it by going here. So here you can see that already there is like an option to activate that the program would like choose the elements of mass from the definition we did in the load pattern. So either I click this and I click this. So when I click this, I can choose other parts like the superimposed loads to be included in the mass source. So I said they are multiplier to 1 because I want all their contribution to be accounted for. And then I click on live, and live most of the time is 0.3. That's what is suggested by the code. I can show you here. You can see that from table 4.3 directly you could take a cut size C, which means that for dead loads 0.3, because of our building, let's say it is a residential building, so I can take 0.3 as the participation. So now when I'm done with that, it means like now I consider all the dead loads and 30% of the live load to be like the seismic weight of the building. Also, maybe like let's say that if I didn't want this, the program to calculate itself, so I can either do this and set this to 1 and add it in the list. In that case it is the same as not choosing this one and involving it in here. So either way is correct. I click OK. So before you go any further, I think it should be good that we do like an analysis and see if we did the right modeling and check our period, everything, before we can do further edits. And to run the analysis, you come here, you do run. Normally I see there are like new SL1 and WL1. Oh, okay. Or just let's before we do this, let's check where those things they are coming from in the load cases, because we don't want this. Also remember that we have like the dead load or the wall load, this one on the outer perimeter beams. So we have to assign this as well. So but we don't have it on the roof. So how we do that? I come here and I don't want to see the slabs. In my case, let's remove them from the view. So S14 select, I selected them and I click on remove selection from view. So now we are not seeing them. Also so in order to select the beams, the perimeter beams, I have to set a view like this one. So as you can see, I just set a view like this one, and let's see if we can try to select the first 3 stories. So yeah, you can see I can select the beams, but also I'm selecting the joints, which I don't want. So I don't want this joint also in the view. Can come here and click here not in view for joints, and I click on apply. So when I do that, I think now I can easily select the first 3 rows easily. Okay. Now I think I'm sure that I'm doing the right selection. Okay, so let's change the view. Now you can see that I only chose the perimeter floors or the perimeter beams alone, so I can go ahead and assign the wall load immediately. And remember that we don't have the wall load on the roof. Come to assign flame loads distributed. I choose here, I choose the wall load, right, which is 6 kilonewton per meter. I click on apply, and then there you have it. See that I have the assignment is done. I think you can come here and select one beam, and select one beam and check if the assignment is there. Okay, you can see, yeah, the assignment is done perfect. So now the next step, I think you have already assigned. I can bring back all the things that I hid. Next step, I think, is we can try to check if really our model is working well, because I think we did the mass source definition, and yeah, you can try to run the model and see if we did where the modeling, there's no any error in the modeling. And also can also bring the again the joint in the view, and check the period. We do a model analysis and check the period to see if the period that we get, it makes sense or not. So to do that, I come here on run analysis. I choose not to run everything, or run everything, but except for these 2, because we haven't, I don't want to run these 2. So I come here and set the action to do not run, because we haven't defined already like where the earthquake loading. So I can click on run now. Yeah, so as you can see, we just started from the model 1,